food pyramids, food webs, and food chains. To start, the real distinction between a food chain and a food web is that a food chain is only going to have one link, whereas a food web is actually many food chains combined and connected. And in food webs, you might actually have one organism occurring at multiple levels. Make sure you know the names for all of the trophic levels: primary consumer, secondary consumer, etc., as well as the difference between omnivores eating both meat and plants, herbivores only plant eaters, carnivores only meat eaters. I feel like most people have a pretty good understanding of these, but just to emphasize that we are not starting with the sun, even though the sun is providing energy. We're just sort of curious about the food systems here. So you just start with producers and then move up from producers. Okay, let's just cover the main types of ecological pyramids and then go into some specifics. So we can use these to look at how different pollutants will collect in organisms, and we can see how we have less energy at the tops of food chains due to the 10% rule. So the three main types, we got pyramids of numbers, where we just count the organisms, we find out their population. These are super easy to implement as long as you can get population data, but they're pretty basic, right? And they could be inverted, so you might have one tree supporting a host of caterpillars, supporting a family of birds, for example. In a pyramid of productivity, this one is going to show the flow of energy through trophic levels. So we can use this to compare different ecosystems. It's going to take way more effort to collect data, though. And because this unit is always a time measurement, usually we're going to have to collect multiple pieces of data to get that sort of view over time, right? How is the energy changing over time? How is the mass changing over time? That's really what productivity is, right? It's all about how things change through time. How much an organism grows is their productivity. The biomass, on the other hand, is a snapshot, right? A snapshot is like just 1 second, 1 instant only. If I take a snapshot in the winter, it's going to look a lot different than it does in the summer. And actually, these biomass pyramids might not also follow the 10% rule, right? We saw that in our example over here, exploring biomass pyramids. Oh, is this not loading? Okay, it is loading. Good, good. Ooh, you can hear the nice river. Okay, thank you, river. You know what you sound like. So you came through here and you scraped some algae, right? And then you predicted that there would actually be 0 catfish in the pool. Well, that's our count, but right, we collected a really small amount of algae. We predicted that based on that small amount of algae, there should be no catfish. When we actually measured it, we found an inverted pyramid. We found a little bit of biomass for the algae and a ton of biomass for the catfish. And so it's kind of confusing, right? How does that tiny bit of algae support this huge amount of catfish? But that's the problem, right? We're just looking at one moment in time. We're not looking at how much these catfish grow compared to how much this algae grows. And if you look through time, you can see that the algae is growing way faster than the catfish. So here's your time in days, and then the accumulated biomass, so how much growth is occurring. So if you just look at the initial start, right, it seems like there's not a ton of algae. But if you progress through time, over a full year, right, you have almost 30 grams of algae per square meter, compared to about 10 grams per square meter for catfish. So that's the idea of productivity, right? You probably can see that intuitively. A lot of plants tend to grow a lot faster than a lot of animals. They tend to have a higher level of productivity. And so that's why a pyramid of productivity is so much more effective, is so much more accurate, because it includes time, because it includes differences in growth rates, right? This is sort of assuming that algae and catfish grow at the same rate through the year, but it's likely that they grow at, well, actually, we're in a tropical rainforest. They probably grow at the same rate. Here in the desert, things might grow more when there's more water available during the monsoons. In northerly places, they'll probably grow more in the summer compared to the winter. But really, that's the big idea, right? Are we looking at total growth over time for productivity, or are we just measuring the standing crop, the biomass at one particular instant. And that will give you a completely different picture, basically. Yeah, so we can see some examples again here. And our biomass pyramids might be inverted, especially aquatic systems, right? Phytoplankton are tiny little microorganisms in the ocean, which are eaten by other tiny little microorganisms, which then are eventually eaten by small fish. I mean, you could think about like in the oceans too. You get those giant whales that survive basically off of krill, right? So these things are super tiny and probably have a really, really small mass compared to the biggest creature that's ever lived. Blue whales are actually bigger than any dinosaur they've discovered, and they're eating one of the smallest things, right? So if you look at the snapshot, it might seem like the pyramid is upside down. But if you track the growth of the whales and the growth of the plankton throughout the whole year, you'll see that it still follows the 10% rule because you need to have enough energy to pass on, right? So pyramids of productivity so much more useful than pyramids of biomass because we're actually accounting for energy that's being lost to respiration, and then we're actually looking at what energy is moving through the system, what energy is being passed on throughout the years. Great.